Hello and welcome to this video on what is a cross-level interaction. My name is Geiser. I'm an instructor and statistical consultant with QuantFish, and on this channel I present weekly statistics tutorials. I usually talk about multivariate statistical methods including factor analysis, structural equation modeling, multi-level analysis and latent class modeling. If this is something that interests you, please subscribe to this channel. Also check out the description for additional resources including workshops that I offer for QuantFish. In this video, I want to explain what a cross-level interaction is. So let's get started. Where do we find this concept of a cross-level interaction? We find that in multi-level statistical analysis, where we have multiple levels of analysis, in the simplest case, an individual level and a group level, or in longitudinal data, we have at level 1 the time points and at level 2 the individuals, where the time points are nested within individuals. Now here I'm going to talk about the case of cross-sectional multi-level analysis, where level 1 are the individuals and at level 2 we have groups. For example, we may have students that are nested within school classes. And so in a multi-level model with two levels, we then have multiple equations, multiple regressions, and we start here with level 1. At level 1, in the simplest possible case of one outcome variable y and one predictor or independent variable x, we have an equation that looks like this, or that may look like this, where yij indicates the scores on a dependent variable, or the score of a dependent variable of individual I who belongs to group J. So for example, a student I who belongs to a school class J. And this dependent variable is predicted in a level 1 regression equation with an intercept beta 0j, with a slope coefficient beta 1j. And then there's a predictor, xij, and there's a residual term rij. Now, for example, we might imagine that we predict school achievement scores from the number of hours that a student studied, for example. So then y would be the outcome achievement score, and x would be the number of hours that an individual student has studied or has done homework. Notice that in this level 1 model, both the intercept beta 0 and the slope beta 1 may be random coefficients. And that is the case here in this example. And that's critical for the idea of a cross-level interaction, because we can only have a cross-level interaction if we have random coefficients in our level 1 model, specifically if we have a random slope. What does it mean to have a random intercept and a random slope? It means that the values of beta 0 and beta 1 can vary across school classes. So each school class can then have a different intercept of this level 1 regression, and also could have a different slope of the regression of y on x. And that's why those are called random coefficients, because they can vary between school classes. At level 2, we then have an equation for beta 0j and also for beta 1j potentially. So in this case, we have both a random intercept and a random slope, and we predict both the random intercept and the random slope with a level 2 predictor wj. So this is a school class level predictor, such as, for example, the class climate or teacher-related variables that do not vary for students who are in the same class. So let's assume that this is, for example, class size. Could be another predictor at level 2, where some school classes maybe have 20 students, others have 25, others have 30. So there's variation in the school class size, the number of children or students within each class. But for students who belong to the same class, this number wouldn't vary, because everybody who is in, let's say, class number 1 has the same class size or is exposed to the same number of peers in that class. So that is therefore a level 2 predictor that does not vary between the level 1 units that belong to the same school class. And so here in this example, we have a random intercept and random slopes as outcomes model, so to say, at level 2. So both the random intercept and the random slope is predicted by W. So we are trying to explain differences in both the intercept across school classes and the slopes across school classes with our level 2 predictor here. Now, so far, no interaction, right? You don't see any interaction term that you might be used to from conventional single level ordinary least squares regression analysis. We know that an interaction term involves a product of 2 or more variables, and there's no such thing here. So those are all just simple linear effects, no interaction so far. Now, I'm telling you, though, that in this model, we do have a cross-level interaction. And how do we see that? How can we visualize that or depict that? In order to do that, we can combine our equations. So we can formulate the same model in terms of what we call a mixed effects model or a mixed effects equation, which simply means substituting what we have for the intercept and for the slope at level 2. So if we put in what we have for beta 0j, the random intercept here, and also if we substitute what we have for beta 1j from our level 2 equations into the level 1 equation, we can express this entire multi-level regression model in a single equation. And that's then called a mixed effects equation. So let's do that. Let's proceed and let's take a look at what happens when we insert those level 2 equations into the level 1 equation. And so when we do that, the model, the combined model, first of all looks like this, where here you have what we got for the random intercept, and then here you got what we have for the random slope in the level 2 equations. And now what we can do is we can expand this equation and we can rearrange the terms a little bit more neatly so that we can see where our fixed effects are and where our random effects are in this mixed effects equation. And so when we do that, we can see that here on the left-hand side, I arranged all the fixed effects, and those are really the ones that we care about the most, so to say, right now. All the fixed effects involve gammas, and gammas are constants. Those are the level 2 fixed regression intercept and slope coefficients from the level 2 regressions of the random intercept and random slope on the level 2 predictor W. And so the gammas are all fixed, they're all constants, unlike the betas, which are random coefficients. And so here we have all the fixed effects, and then here at the end we have random effects that involve the U and R terms, which are residuals. The U terms are the level 2 residual or error terms, and the R term is the level 1 residual or error term. So those are all at the end, and they're not so interesting for us right now. What's interesting to us are the fixed effects, and you can see that then in the combined or mixed effects multi-level equation, we have an intercept gamma 0, 0. We have an effect of the level 1 predictor, which is quantified by the gamma 1, 0 constant regression coefficient. And we have a simple effect or main effect, so to say, of our level 2 predictor, Wj, which is measured by gamma 0, 1. And we also have an interaction term. So this is highlighted here in green. And you can see this is an interaction because this involves the product of Wj times Xij. So that's the interaction between our level 1 predictor X and the level 2 predictor W, and that's quantified with the regression coefficient gamma 1, 1. So if gamma 1, 1 is significantly different from 0, this means that there is a significant cross-level interaction. Now, where does this come from? Why do we all of a sudden get this product term that previously we didn't see? It's because when we expand this portion here for beta 1j, then we get one term that is gamma 11 times wj times xij. So that's where this product comes from, which shows you that you can only have a cross-level interaction in models with random slopes. If your model only has a random intercept, beta 0j, but fixed slopes for the level 1 predictors, then there would be no such thing as a cross-level interaction. So really what is critical for the cross-level interaction is that there be one or more random slope coefficients in your level 1 model, where the random slope then is predicted by a level 2 predictor. So what does this mean now from a substantive perspective? It means that our achievement scores could be predicted by study time. So study time may be a predictor of achievement, and then also the class size itself may be a predictor of achievement scores, and also the interaction between the class size and the number of hours studied, such that perhaps students who are in classrooms that are larger, for them maybe the amount of study time has more or less impact on their achievement scores. I don't know if that makes sense, but this would be something that we could test, whether this effect is conditional, whether the effect of number of hours studies depends on whether a student is in a smaller class or a larger class. And that would be quantified by this gamma 11 coefficient that indicates the cross-level interaction effect. I hope you found this video useful to learn more about multi-level modeling and what a cross-level interaction is. If you're more interested in multi-level analysis, check out my QuantFish workshop on multi-level analysis with Mplus. Also, there are other workshops available in the description, so check those out, and I'll see you next time.